Singleton design. Okay. So we saw in the creational, we have creational structure, behavioral design pattern. And in creational design pattern, we saw abstract factory. So factory, which is an abstract and that need to be implemented and then instantiated. Factory method. Then we have prototype and we have builder. There is another design pattern in creation called singleton design pattern. Singleton design pattern that comes when singleton means a class that can be instantiated only once. When I am free to instantiate it, no one stops us. But repeatedly instantiating the class, so first time it would return the instantiation of the class, but next time onwards it would return the first time instantiated object. So first time object instantiation is possible. From next time onwards, it would remember the instantiation what has happened first time, and then same thing it will keep return. So that is a singleton class. So class that can be instantiated singleton. So singleton class. We'll see proxy proxy design pattern also. Okay, so that comes as a structural design pattern. So why proxy, and there is no relationship between proxy and singleton design pattern. They are not similar. Proxy can be created as many times as possible. But anyway, singleton design pattern, a prime minister is singleton. There cannot be two prime ministers. So if prime minister is a class, then I can instantiate only once. President is singleton. Chief ministers in states are singleton. Okay, so a party president is singleton. So if someone is holding non-shareable resources, then it cannot be instantiated. Like there are few hardware resources that is crucial, and like a tape, a tape on which data is being written, and one class instantiated and it is writing on it. Certainly, if that class get instantiated, it will try to hold it again. Then there is a garbage. So if there is a hardware resources that cannot be shared, in those cases we restrict the class instantiation to only one. So Prime Minister holds chair and authority that cannot be shared. So I mean, in certain country, certain country, president holds the chair that cannot be shared. I mean, chair is the hardware resource, okay, and it cannot be shared. Okay, so wherever he is signing in, whatever the decision the president is taking, so those decision cannot be overwritten by someone else. So he, whatever he is holding, that should be exclusive. So in those scenarios, we have singleton design. So this is the need for singleton design pattern. Class can be instantiated only once. You can instantiate it multiple times, but first time whatever the instantiation is, same thing it will return again and again. So in C++, so idea is that class, so if I consider two data structure, class data structure is different and object data structure is different. When class instantiate first time an object, then it would kind of initialize class attribute, certain class attribute, and next time it is instantiating the object, it would check that class attribute. If it is already has instantiated an object, then same object it would return. So this is a kind of blueprint. So in C++, there can be a static pointer to the class itself, and constructor will make it private. So no one can instantiate to traditional ways. Since constructor is private, no one can instantiate, and there is a static pointer to itself, class pointer, and there is a static function called get instance public. And if you call get instance, it would instantiate since uh, class variables they can class member function they can access private. From outside you cannot instantiate. So a static function get instance can instantiate provided the static pointer is null. So first time it will instantiate and next time it will return the same object what it instantiated the first time. So this is the ground. And if we see a Python code, then in class we have a function called new. These are special functions. Underscore, underscores, new, underscores, underscore. So new gets called whenever class is getting instantiated. So inside the new, similar kind of we can check we can make. We can have a class attribute and that will keep the class object when first time it is instantiated. Next time it will return the same. But there is a problem here. If see Python supports multiple inheritance. So if a class inherit from two three classes, then there is a hook. There is a problem in the sense that new can be overwritten if I do the like if I have a singleton class and it has new function implemented, then if I have other classes and I derive from singleton and other classes, then singleton whatever the new it provides other classes, okay, because it will call every so if I have a class A derives from singleton because we need a singleton, and then we have another other classes from which A derives. So in the A new, we call the thing. So A new should call everyone's new, and singleton new does the magic, but other new can do the they can crook the magic. Okay, so for that, in Python, what we do is we explicitly set meta class. So in Python, there are three layers: object, object class. So objects class is class. Classes class is meta class. So the special functions, the special functions like if I call a class or object through function, like if A is a class, so against capital A, I call A like a function, okay, or A has instance called IA, and IA I call as a function. I can call it, but underneath it would call a special function called underscores underscores call underscores underscores. So if these are special functions, then it will go in their class. So if IA is an object of class A, and against IA if I call, make a function call or called method call, then IA's class is A, there it would call. If I call capital A and function, then capital A is meta class dot underscores call, there it will go. So yeah, whatever the structure we are making the function call, that structure's class, there it would go. So if I have a class A and then I derive it from B, C, D and meta class called meta, then if I say A and then against A I make a function call, this is the way A get instantiated. Now against A's meta class, I can override underscores underscores call underscores function. If I override, then my call will get called. There, same story. I would remember something and then I can call super. Okay, so inside the call, inside if I am hooking the call, then I have to call super call. The call in the meta class, finally it will call the new against the class. So there is a meta class, there is class, and there is object. So if I call function, okay, function type against a class, then its superclass call special method will get called, which will internally call new against the class. Inside the new, the class would get instantiated in the object class. That is the parent of all the class. And finally, a new object would get created. So in the call of superclass, there, okay, so there it called the class new. There I place a hook and this class, then if I place a hook, then I should call the meta class, that is super call. So there is a meta class. There is a meta class. Meta class has a special function called underscore underscore call. So if I instantiate a class underscore underscore call gets called, I override it, and by default I should call the super call as per the default implementation. I would remember it first time, and whatever the super call returns, that is the class object. So that that I would remember it. Next time I won't call it again. So now multiple inheritance is supported in this fashion. So meta class is only one for each class. There can be so many classes. It derives from a class in Python can derive from n number of classes, but it will have only one meta class. So meta class underscore underscore call will get called, and there the first time when call goes through, it returns the created object. So so whatever. So first time I let the call go through. I don't care. Okay, but next time I won't let the call go through. So okay, so whatever the first time the call returned or something like that, I would return same. So this way, in Python, if I have a class A and derive from B, C, D, then I can set meta class as meta, and that overrides underscore underscore call. First time things would go fine, and it would remember whatever happened, whatever object got created. Next time, if someone call, it will return the same. So B, C, D, their new will not get called at all. So from the second time. So this is singleton class. So singleton class in C++, we achieved through static pointer and a static get instance function, and static pointer can be private, and whereas in Python we achieve through meta class. There we override underscore underscore class first time it goes through, we remember it like a get instance in C++. First time it passes through, we remember it, and next time we return same thing. Here in meta class call, we remember first time. So meta class call, the default call calls the new of the class. So everything should go through fine first time. Second time it will return the created object. So this is the way the singleton is implemented in C++ and Python. Why proxy design pattern? Suppose that I have a heavyweight class or lightweight whatsoever. It cannot be instantiated second time. Now in a process, I instantiated in one time. Okay, but due to my architecture or change in architecture, I need multiple instances somehow. Okay, so when I wrote the code, I made it singleton, and I have to make it singleton because it is president or prime minister of a country. It is holding hardware resources. So next time when it is working nice, but architecture change. Like I have a I made my process. My web server is very slow. One time a request comes in, then the class I instantiated inside the web server process, it serves the client. Next, whatever the request comes in, generally I get 10 to 20 requests per minute. So it serves or it queues. But business goes on, and now it is serving 10,000 requests per second. So that much is not possible. Either I can queue it or I made it multi-threaded. Even though I made it multi-threaded, but class instance has to be there because this is the code that is written. So in a class, in a process, if I have 10,000 requests coming in, suppose I created somehow 10,000 threads, and my machine supports it, then every thread needs a class instance because this is how it is written. What to do in those scenarios? If it is a singleton, okay, then we'll go with the proxy design pattern. And if I have a class that can be instantiated only once, it would derive from an interface now. This is what is required. So there is an interface. From the interface, my class is derived. So interface has template methods. It realizes the template method very nice. From interface, I derive a proxy class also. So from same interface class, I derive my singleton class. From same interface, I derive the proxy class. Now proxy I am instantiating 10,000. So proxy has template method, and my threads are calling the process function the way and earlier it used to call. So earlier things were very smooth because I was getting 10, 20, 30 requests in a minute or something like that. But now it is 10,000. So now every thread has a class, but those are proxy classes. They know that what to do. My program is exactly same, no change. So business is fast, everything is fast. Now someone wrote the proxy, and proxy deals with the actual class through inter-process communication or through socket or whatsoever through named pipe or through shared resources whatsoever, and then work is done. So internally, all the functions that are implemented in the proxy are just delegation, and they know how to do marshalling and demarshalling of the request request and reply that goes to the actual class instance, singleton class instance, and what to do. So very nice. So singleton class we can implement, and then only way that singleton class would work in a way where thousands of instances I need, that is the proxy design. Because both implement same interface, and then it is something like we can bluff something. But anyway, what is it? Proxy knows how to interact with the singleton class. So that's how it is. So singleton proxy go together. Okay. So only earning and no headache. So that's what we can do with the singleton.